So Terence Broad is an artist and researcher working in London. He's a senior lecturer in creative AI at the Creative Computing Institute, University of the Arts London. He holds a PhD from Goldsmiths, University of London. As an artist and researcher, Terence has been involved in the creative AI space since 2016. For the last 4 years, he has been teaching AI in the context of an art school. He has developed a pedagogical practice centered around holistic and ethical approaches to building and utilizing custom AI systems in creative practice. His art and research has have been presented internationally at many conferences and journals such as SIGGRAPH, Leonardo, etc. It's countless. I won't list them all. He won also in 2019 the grand prize in the ICCV Computer Vision Art Gallery and serves regularly as a jury for SIGGRAPH. So thank you very much, Terence. The floor is yours.
Yeah, thanks, Gaetan, for the invitation and thanks for organising this event. I think it's a really important thing to be talking about, and I hope this is the first of many. So you've really kind of given me an introduction, but I'll just sort of cover this. So I've been at an artistic practice working with generative AI for 10 years now, and for a significant amount of this time, I was doing a PhD in computer science at Goldsmiths, University of London. And maybe ironically, my entire PhD was about using generative AI without using data. This example on the left is a project I did where I was training AI without data. But before my PhD, I spent a couple of years working as a research scientist at a startup called Vivacity Labs, which was working in the field of computer vision for transport systems. And my main responsibility was kind of training AI models on these kind of custom data sets, but I was really spent a lot of time managing these data sets, and a lot of kind of my teaching has kind of come from the experience of doing this practically in the real world. So yeah, I've been working full time for 4 years. I've been teaching at CCI for 5 years. So Creative Computing Institute is a research institute at University of Arts London, and it's Europe's largest art and design higher education institution. I primarily teach postgraduate students with backgrounds in the arts, so people have done various kinds of arts degrees in the past, and we teach conversion courses that are MSc programs that cover skills in coding, kind of foundational maths you need to learn for AI, how to build and train your AI models and how to use them in creative practice, how to build interfaces and interactive systems around them. So I primarily teach on the MSc Applied Machine Learning for Creatives, which was formerly data science and AI for the creative industries, but I've also taught on some of the other creative computing programs at CCI. So when I started teaching in 2021 at CCI, we would normally teach kind of classes were structured in a very sort of regular way. We'd have a lecture on a technical subject. It might be GANs, it might be recurrent neural networks, something like that. And then we do a lab activity where the students would run some kind of pre-prepared Python notebook, a Jupyter notebook, usually running on Google Colab. And so it would look something like this. And it would usually be sort of something where we might train a certain model and talk the students through the steps of that, and the students would just kind of hit this big button at the top of Colab, hit run all. They would ignore all of the kind of things that we'd written, spent a lot of time putting in some cases, and just sit and then watch something train, spend half an hour watching a model train. It was very passive. They weren't really kind of being particularly engaged in the content that we were delivering. And then when they did their individual projects, they would go and find a data set on a website like Kaggle, and often they would then find a code notebook associated with that. Maybe if we were lucky, they'd make some sort of changes to it and then submit that as their own work. And I was getting very frustrated that the students weren't doing more creative projects, weren't really more sort of invested in this. But I think kind of on reflection, the teaching we were delivering was just teaching students how to run notebooks we were giving them, and it wasn't really a surprise that when we asked them to do their own projects, this was kind of the thing that they only really felt confident doing was going and finding code from the internet and maybe making small changes to it. So so this kind of experience was very passive. The students ended up being very unmotivated and had very little ownership over what they were doing. There was very little continuity between the classes, so students weren't sort of developing a project over time, developing those kinds of project management skills that we were hoping for. And then they weren't really doing much problem solving, especially again over a sort of sustained project that was developing over time. And students really ended up lacking a lot of confidence in developing their own ideas, working on their own projects. And even when it came to the kind of thesis projects, it was quite hard to get students to sort of have the confidence to do their own work. So in the last 5 years, I've made a number of changes. Broadly, we're moving from working on primarily individual projects to trying to do more work in group projects. Um, all of the classes in the past were based on existing data sets, and all the projects the students did a lot of the time were based on existing data sets. So we're trying to move students towards creating their own custom data sets and classes being focused around that, which is what I'll be talking more about. And then where we used to ask students to submit the notebooks that they use to train the models as kind of their project submission. Now they submit a data set they've created and some kind of interactive AI project that makes use of that data set, whether it's a model trained on it or various other ways that that could be done. And instead of written project reports, because of ChatGPT now, students are assessed on kind of presentations and demos of their work that they give in person. So I've got a number of golden rules now that I sort of very strictly stick to when I'm teaching AI. So when students are submitting projects for these AI units that I'm teaching, they have to use an original data set that they've made themselves. If they don't use a data set they made themselves, they'll fail. That's the sort of strict rule number one. And, to sort of as I'm teaching to get students into that mindset, whenever we're doing activities in class, whenever possible, part of the activity will be them making a data set. So usually doing some kind of simple web scraping task, maybe kind of some kind of image classification, getting data to train, a LoRa for a diffusion model, something like this. But, we really try and get students to actually make data sets in the class quite quickly and rapidly, and then use that then as a thing to train with. So it's a preliminary step of an activity. Sometimes that's not always possible, and when it's not possible, if I'm giving data sets for the students to run in a class, then it has to be an original data set that I've made. And I will then provide all of the code and documentation of that data set with the students as an example for when they're kind of then making data sets themselves for their assessment. And so why this sort of really strict emphasis on original data sets? Well, if you've never done this before, training an AI model on a new data set that you've collected yourself can be very difficult. It very, very rarely goes as intended first time of asking. So, you create your data, you'll train something, and then it often is not what you intended. So then you have to sort of start to understand, okay, what's going on in the data? Why is the model not picking up on these things that I hoping it would during training? And that kind of is a process that then students have to go through themselves. And in addition to that, good quality data sets are really essential for AI to work well. So that's something that, again, is easy to talk about in theory, but it's hard to sort of really understand what makes a good quality data set or how that works until you've really put that into practice and done this yourself. Um, and I found that students feel a lot more ownership of their own work when we do this. So compared to when, they were just using data sets they found from the web. So the students are more engaged, there's more obviously they've got a sense of ownership, and it's also a vehicle that they can engage their own interests. And so really encourage students, whatever it is that they are interested in outside of the university, they can start to engage those interests through the kind of data that they're collecting and engaging with. Um, and finally, this is a really tangible way to engage with and for students to engage with the ethics of kind of data, the ethics of data collection practices, categorization, and AI literacy, and then also it's a way of us to assess their engagement with these things. And so there's a sort of final golden rule that I have. So if I give a data set to a student that I've made, or when the students give me a data set that's used part of their assessment, then it has to be documented with a data sheet. And if you're not familiar with data sheets, this was a concept came up with by Timnit Gebru and collaborators in 2021, and it's basically just a structured series of questions, a questionnaire that you answer the idea is for when you're publicly releasing a data set. But I think this is a good thing for students to do as well. Is it forces you to sort of document the motivation for the data, the composition, where the data is sourced from, any pre-processing steps, licensing and legal things, and ethical considerations of the data set. You know, what it's intended for, but what are the potential uses that it shouldn't be used for. And on top of this, this really then sort of actually forces the students to reflect on and situate their work within these broader debates of data bias and the social impacts of AI. And so students can make data sets in lots of different ways. You know, I'm not prescriptive in that. You know, we've had students use personal archives of their creative practices from, you know, their personal practice work that they've done in previous degrees. They can go and collect data themselves using cameras, using Photoshop, using mic recordings, whatever. Um, they're allowed to collate data from various archival sources. So as long as they're not just sort of they're kind of sourcing data from lots of various places, then that can be a way of making a data set from existing archives. And then web scraping. So scraping data from social media using kind of the APIs that are provided by the platforms, or building web crawlers. And you know, there's some ethical things that have to be done, thought about when teaching those things, but it is something that we allow. And um, you know, in the context of non-commercial academic research in the UK, this is something that's a legally valid thing to be doing. And or they can generate synthetic data sets using software. And then depending on the unit and assessment, what they're doing, the students might be training a model from scratch, fine-tuning a model, training a LoRa, or they could be using the data set in inference, so something like information retrieval, more recently things like retrieval augmented generation or agentic workflows. And something that I'm sort of starting to introduce more now is how data sets are used in alignment post-training methods. So things like machine unlearning data sets can be used for that as well. So I'm now going to give you an example of 3 projects of students that I've taught who've graduated from the Creative Computing Institute, who've done projects where they've made their own data sets that have got international recognition. So the first is Adam Cole's project Kiss Crash. Alan Cole was a student on the MSc Creative Computing in 2021-22, and I was teaching him the machine learning unit on that course. And for the project on the course, Adam was interested in kind of ideas of intimacy, of relationships, and he found this website flim.ai, which I think they use AI to sort of extract frames from films. And so you can search with a keyword, and then it will give you all of these sort of stills from films, and he built a web scraper to then scrape from this. So it was kind of high quality data, but also data that was kind of on a curated platform. And taking stills from films is something that sort of is generally kind of permissible and under sort of the idea of sort of transformative use of data. So he scraped this in my unit. He trained a GAN for his thesis project. He then trained a diffusion model, and he did this project Kiss Crash. I'm just going to quickly play some of this. So that it was a short film. It was about a minute long. It was also shown in installation work in his final show. But Adam went on to publish his work at SIGGRAPH Art Papers in 2023, and also the short film was shown at film festivals around the world and won an audience award at South by Southwest in 2024. The next project is Project Marisa Beatty, who was data science and AI for the creative industry student a few years ago. She did this project envisioning distant worlds. Marisa had a background in English literature, but she was fascinated about space, fascinated in particular about exoplanets. And so she got all of the exoplanet data from NASA, kind of the scientific data from things like the Hubble telescope and the James Webb telescope. And then also NASA have archives of photographs of planets and of artistic renderings of exoplanets that they've commissioned themselves. And so she got this data set kind of the visual renderings, the visual images, and the sort of scientific data. And then she went away, did all this mad research, and built a system that could generate a text description from the sort of scientific data, And then she then took the existing renderings of exoplanets and planets in the solar system that we have, used these text descriptions and trained a sort of paired text to image diffusion model, latent diffusion model on this data. And then you could then just take any exoplanet, take the data, put it into the prompt system to generate a text prompt, and then it would generate these really stunning renderings. And Marissa presented this work at the Neurops Creativity Workshop in 2023. And then the final project I want to talk about, another image generation model, was Ina Hresk, who did this project of sort of sketches to fashion photography. Again, she was a graduate from the same program as Marissa a year later. And Ina had a friend who was a costume designer and had a professional practice as a costume and textiles fashion designer. And so she had this whole archive of, fashion sketches, of costumes. And then Ina herself was had a sort of side hobby as a fashion photographer and actually had photographed a lot of the work from her collaborator. So they had these two personal archives, one of her of the fashion sketches, one of the fashion photographs, and then she trained a sort of image to image model. And this was done in a sort of co-design research methodology. So the the costume designer was part of this process and was giving feedback throughout this. So from the sort of aggregating the data and training the first preliminary models, feedback was given to sort of make sure that it was kind of within the sort of style that she was looking for, and then kind of the more sort of the workflow of like how this could be used for taking new sketches and generating renderings without having to sort of actually produce all of these costumes for clients. So it was a way of kind of sort of speeding up the workflow, building a sort of bespoke system based on this data. And it was a very successful project. The costume designer loved it and I think still uses it now, so she can sort of speed up this process. But it's used to kind of give examples of renderings to sort of clients for potential pitches for projects, but it's also kind of used as a source of inspiration. And again, went on to publish this at the International Conference of Computational Creativity last year. So I'm now going to sort of just give some reflections, and I'm going to talk about kind of what the data set is. So the data set really is a number of different things in a number of different contexts. And when we're using this for teaching and for assessment, it really stands as both a technical object as well as a cultural artifact. So it's kind of both at the same time, and also it's a mode of us sort of a mode for pedagogy, a mode of assessment. And so I'm going to sort of go through what I mean by these one at a time. So if we think of a data set as a technical object, then the data set is really primarily an object for machine consumption. It might be curated by a person, but it's designed to be consumed by a machine. It's either kind of used in retrieval or used in the training of a system, and it's really often a means to an end. So if we're in the context of training, it's a means to induce these desired biases, desired behaviors within a statistical system, a neural network. And so when you're kind of developing a data set through the lens of it being a technical object, it has to be uniform. It has to be uniform, and it's kind of often it's encoding and it's formatting and it's sort of the more sort of subjective sort of structure of it as well. And you need to have kind of things like consistent structured metadata. It's very easy for code to break if you get this wrong. So there's sort of formal technicalities that have to be consistent and uniform. And it also is something that has to be tractable. So if again, using this for training or fine-tuning, you're building something that can be learned from. And doing that well is something that takes time and skill. But the contrast to this is the data set as a cultural artifact. And so the data set is, as well as being something for me consumption, it's also something that's constructed, curated representation of particular human values and particularly like the students' values. And again, it's sort of a statement of intent of how you would want a model to behave. Doesn't necessarily work out that way, but it's sort of we can think of this data set as it's something, it has an intended purpose, and it's often its intentions are kind of describing how something should or shouldn't behave. That statistical system. And the dataset should reflect the dataset kind of reflects both technical and artistic considerations. And we can view these through a cultural lens, or we can view these through a technical lens, but it's both at the same time. It reflects kind of individual biases of the person creating it, kind of the wider social biases and the broader historical perspectives of that person. All these things are intertwined. And it's really a multitude of subjective decisions that constitute a whole and need to be kind of viewed as such when you're reading these things. And what I'm looking for when I'm assessing data sets is that a good data set is motivated, is created and motivated by a specific practical use case for a project. That's always a framing that we give to students. But while they might have a specific use case in mind, they also need to think about broader use cases of how this data set could be used and reused and potential misuses of that data set. And, as I said, it should balance all of the technical, artistic, and ethical considerations. And usually when I'm assessing work, I'm looking for data sets that have clearly kind of evolved in conjunction with a broader project development. And then when students are evaluating the data set, at the end of the project, that data set is being evaluated in the context of the success of that wider project. And I'm on 20 minutes, but I'll quickly just say this. I think it's important that you give students a strong ethical framework of how to approach these things before you set them off to do it. It can take a long time for students to make good data sets and then train models with them. As I said, it's a hard process. So if you have a lot of if you don't have much time for teaching and assessment, then think about how you can kind of put constraints on that to make it easier for students. And then kind of the actual legality of how data can and can't be used in AI is still being debated, and we're starting to see it kind of diverging through various legal regimes, and that can be quite challenging when you're teaching large bodies of international students. But anyway, thanks for listening. Happy to take